Hello again, or for the first time, and welcome to another Diggy Doos project. Back in 2017, I came across a custom wooden candy dispenser while shopping for wooden knobs. The dispenser looked good, but I thought I could do better. I give credit to Dave's Wood Designs for my inspiration at www.davewooddesigns.com. I have no affiliation with Dave, but give credit where credit is due. I have purchased dowels and knobs from Dave, and they were high quality. I have not purchased one of his candy dispensers. The picture shown in the background is my version of a candy dispenser which I made as a Christmas gift for my father in 2017. Sometime in 2023 it stopped working and I picked it up to see what happened, and that is the subject of this video. My actual workbench is very crowded with my chipper shredder project, so I cleared a space on one of my computer desks, which is actually a kitchen table. In the first part of this project, I will be taking it apart to find out what made it stop working. It was made from African mahogany, and most of the working parts were printed on my 3D printer. Although the concept and inspiration was from Dave, this project was solely my design and designed using Autodesk Inventor. Later in this project, I will be showing the design files. The slot here on the front will take any coin from a penny up to a quarter to dispense one serving. And down here near the base is a drawer that catches the coins. And obviously, this chute is where the candy comes out. Underneath is a door that holds a 9-volt battery that powers the motor. Now let's get to taking it apart. The globe that holds the candy is actually meant for a light fixture. It is set into a 3D printed funnel and they both just sit on top. There is nothing holding it there but gravity. Flipping it over, I remove the battery cover and the battery, and then the 3 screws that hold the base to the column. Lifting the base off, I disconnect the cables from the circuit board. More details on the electronics will come later. This switch interlocks with the coin drawer and functions as an on-off switch so that it will not function when the drawer is pulled out. And this switch is what operates the dispenser when the coin is dropped in. It is commonly used in vending machines. There are 3 supports that hold the dispenser assembly in place. They have keyhole slots and I only need to loosen 1 screw to remove them. The coin chute is also held in place with only 1 screw. When removed, it slides up and out. The coin chute works relatively simple. The coin slides through the chute and trips the switch when it hits the paddle. Although the dispenser assembly has clearance slots for hardware, they were a very tight fit and difficult to get it out. I also intend to resolve that issue during this repair. Now that I have the dispenser assembly out, we can see what happened. There are 2 idler pulleys for the belt, and 1 broke off. The axle shaft for the pulleys was made of plastic and printed part of the base. I will upgrade this to use a brass tube. Now it is time to design a new base plate with stronger mounts to support brass tube axles for the idler pulleys. It's been 2 weeks since my diagnosis of the failure before I had time to redesign the base of the dispenser and get one printed out and machined. Reviewing, this is the old assembly and this is the idler pulley that did not break off, showing the plastic axle, and a close-up showing how it was molded into the base. And on this side is the broken axle. This is the new base design incorporating the brass tube axles where one is already installed with the idler pulley. Close-up showing the new axle mounting shelf, which is much stronger instead of the two plastic pins. Lifting the idler off, you can see the new axle. And here is the second axle almost ready to install. The holes for the axles were carefully drilled to just undersize so the axle would be a press fit. I don't want to hammer or press it in for fear of breaking the base. I devised a less forceful way to do it. Once the axle has been installed, it will be time to transfer all the parts from the old assembly to the new plate. But first I need to prep the axle. I cut the brass tube axles using a small tubing cutter, and it left the ends slightly flared out. Leaving them flared will make them difficult to install and possibly enlarging the hole, resulting in a loose fit. A very simple way to correct this is to chuck it into a drill and using sandpaper or a file, chamfer the ends. When doing this with brass tubing, it is very important to only lightly tighten the chuck or you risk deforming the tube. And now it is ready to install. Now the axle tube is ready to install, but I fear using a lot of pressure to push it in because it could break the plastic. What I did to reduce the possibility of breaking the plastic, I chucked the tube back into the drill and more or less screwed it in. It worked extremely well the first time, and now we'll see if it works again. I used the idler pulley to set the spacing in the chuck, which left it just barely too high. It was easily pushed down flush with the top of the pulley using the handle of a screwdriver. Now everything is ready to assemble, but first a quick review. Here is my very crowded and unorganized work area. First is the drive motor, which I have partially pulled up out of the housing showing the gear train. Then we have the new base plate with the new idler pulleys installed. And over here is the dispenser motor and drive belt. This is the candy output chute which mounts under the base plate. And here is the coin chute. On the base of the machine, here is the coin drawer interlock switch, and sliding the coin drawer in shows how that works. And a PC board where the cables are connected, but what cannot be seen is the circuit underneath where there is a switching transistor and associated components. The gray plate is the back end of the battery housing. Now it is time to get this thing reassembled and see if it works. First part of the reassembly is putting the dispenser back together, assembling the motor to the base, as well as the rotor, drive belt, output chute, and interlock switch. Up in the corner is an illustration from Inventor showing how it all goes together in the 3D modeling world. And although I did not have to reassemble the coin chute, there is also a video in the corner showing how it goes together. With the battery reinstalled and cables connected to the control board, it is time to see if my repair was successful. Dropping a coin through the coin chute and...
Oh no!
Nothing happens. A few seconds of thought analysis, and I remembered that this knucklehead forgot to connect the motor.
No!
Now with the motor connected, dropping a coin through the chute and the motor fires up and the dispenser rotates 90 degrees, but the motor sounded like the belt might be too tight because it was struggling. A quick adjustment to the belt tension and the motor sings right along. It appears that this repair was successful and now it is time to reassemble the machine. Now it is time for the final assembly, but first I need to glue down the switching SCR and associated components. For this I will use hot melt glue. This is the SCR, and in the green heat shrink are some resistors, and they also need to be fastened down. A little blob of glue in the corner and press the SCR down until it starts to set up. Now another blob of glue and then some more for the resistors, and again I will have to hold it in place until it is cool enough so that it does not move. And now the dispenser assembly is complete. I slide the dispenser assembly in and around the hardware and set it at the bottom. Well, actually it's at the bottom of the top. I made the hardware clearance slots larger on this one and it goes into place much easier. It is held in place by these 3 brackets that have keyhole slots that fit over screws. I push down against the dispenser and then tighten the screws. Now for the coin chute. It slides down onto a screw, but installing the other screw is a bit tricky because the screwdriver is at an angle. Attaching the connectors to the control board, and now, before screwing the base down, I will flip the switch and make sure everything is still working.
Woohoo!
To fill the globe, I just turn it upside down and pour in the M&Ms. I'm getting nervous. The moment of truth is approaching. To mount the globe, I just position the machine on its side and then just slide it into the funnel. The screws for the globe are not really necessary, but it does add an aesthetic touch to it. I slide in the drawer, and now I have to go get some coins. Hold your breath. Cross your fingers. Here it goes. I confirmed it works with a penny, dime, nickel, and quarter. Now it is time to return it back to the customer. If you're curious, stay tuned in for a few more minutes to watch the illustrations from the modeling world of how it is all assembled, as well as a quick discussion of electronics and switching. I've been thinking of making another one of these to show how it is built. Here is the motor control circuit diagram. The PC board that is mounted on the base contains resistors R1 and R2, a capacitor, and a switching transistor. The coin trigger switch is illustrated at the bottom left. When it is triggered, capacitor C1 is charged, turning on transistor Q2. Following the circuit up to the motor switching circuit, it provides a gate signal to the SCR, turning it on, which in turn starts the motor. An SCR is a device that, when turned on, will stay on until current through it goes to zero. The capacitor on the base of Q2 keeps the transistor on until the rotor rotates far enough to switch the rotor interlock switch to the on position. Now, with current flowing through the SCR, it keeps the motor turning until the rotor interlock switch is turned off after the rotor goes around 90 degrees. The last part of this video will be from Inventor, showing the explosions and how everything was assembled. I hope you enjoyed the video of this project and it was an inspiration for you to go out and create something new.